Okay, ladies and gentlemen, we have part 2 of our Chapter 7 review. So we left off yesterday proving that they're inverse of each other. We're going to begin here, number 8. Number 8, find each of the following given that h of x, j of x, k of x are the following. Okay, and what we can do here is, if you look at the first one, each of these is different. Okay, so the first one is just a minus. Now when you're doing this, your h of x is 3x to the 4th. Minus, when I just put in there j of x, I have to put parentheses around my j of x, 5x minus 2. Okay, now this minus sign gets distributed across. 3x to the 4th minus 5x plus 2. Okay, that's it. That's really all you're doing. You're done. Okay, like that's finished. So it's that simple. K of x over j of x. My k of x is the 4th root of x minus 5 divided by 5x minus 2. Done. Okay? Like you have your k of x on top, you have your j of x down low. That's it. That's all I can do with that. Okay? Lastly, this is the composition. You're working inside out. The inside is k of x, which is the 4th root of x minus 5. My h of x is 3 something raised to the 4th power. Can you guys see that? H of x, h is on the outside. So the thing I put in the parentheses is this 4th root of x minus 5. Okay. Now, good news. When this go ahead and when you raise the 4th power, I get just x minus 5 underneath it. And I can distribute the x or the 3 in, 3x minus 15. Okay, write the domains for A, B, C in interval notation. Part A, h of x, j of x. I mean, look at my answer here. Am I ever dividing by an x? No. Do I have any even powered roots? No. So my domain for the first one is negative infinity to positive infinity. Chances are you're going to see at least one of those. Part B is a tricky one. I got two things going on here. I have an x in my denominator, which I find by setting it not equal to 0. That's my denominator, 5x minus 2. If I solve for this, x can equal 2/5. Okay? But I also have an even power root. X minus 5 must be greater than or equal to 0. Alright, check this out. I need this. This has to be true. So if you look at just this on a number line, here's 5, and I'm saying it's greater than or equal to 5, right? And I'm also saying up here that 2/5, which is roughly around here, I can't have. Well, guess what? Just by saying this, that from 5 to infinity, you are already stating that you can't have 2/5. So this one trumps it. It works. Okay? So, nothing too crazy there. Just take a look at both of them and make sure you have all the things like taken care of. Part C, now again, this is the composition, so I have to look at my original function, which is this, and my end function, which is that. This is fine, but my k of x is the 4th root of x minus 5. Well, same idea. I have to say that I can't have an even powered root or negative under an even powered root. So x must be greater than or equal to 5 again. 5 to infinity. Alright? There you go. So you're taking consideration what your input value is for your composition and also the end. So I know I can't. 5 is greater than or equal to 0. No, what am I talking about? 5 is from 5 to infinity with a bracket. Sorry. It's early in the morning. It's like 9 or 6 o'clock yet. Okay, solve the following. Check for any extraneous solutions. Alright, I want to get rid of the square root. So I square left, I square right. When I square a square root, I get 4x. On the right, I'm doing this. I'm foiling it out. Okay? So 4x equals x squared minus 16x plus 64. This is just foiling, guys. You should know that. I can subtract 4x over. Let's see here. I'm going to try to factor if I can. Can I think of two numbers that multiply to give me 64 but add to negative 20? Negative 16, negative 4. Winner, winner. So x minus 16, x minus 4. Set them both equal to 0. Okay. Checking for extraneous solutions. I got 16 and I got 4. You plug 16 up top here. Square root of 64 is 8. 16 minus 8 is 8. This works. Use a calculator if you need to. Alright. 4 times 4 is 16. Square root of 16 is 4. 4 minus 8 is negative 4. This does not work. This is extraneous. I need you to label that. Okay? If you put ext, I'm cool with that. Just make sure that you're showing, put an X through it, something that shows that answer does not work in the original context of the problem. Biologists have discovered that the shoulder height h in centimeters of a male African elephant can be modeled by the equation h equals 62.5 cube root t plus 75.8, where t is the age in years of the elephant. Determine the age of the elephant whose shoulder height is 200 centimeters. Round your answer to the nearest year. So I am taking 200 and I am plugging it into h right there. So 200 equals 62.5 cubed root of t plus 75.8. Okay, so I need to subtract 75.8 over. $124.2 equals 62.5 cubed root of t. I'm then going to divide both sides by 62.5. $1.9872 equals cubed root of t. Notice I'm keeping every decimal place. Pardon me. Then I'm cubing both sides. So I'm raising my answer here to the third power. Finally, it says round to the nearest year. 7.847. Well, if I'm rounding to the nearest year, that would be 8 years. Okay? Now, important things to point out for this problem before I kind of wrap this video up. I'm telling you guys right now, number one mistake you're going to make. Everyone's going to look at this problem and go, oh, cube root, the opposite of cube root is to cube it. You have to get it by itself first. Cannot stress that enough. That's the number one mistake made. Okay? So before I cube to get rid of that cube root, I have to isolate it. Okay? Please keep that in mind. Other than that, you guys should be in excellent shape. As always, keep the good work and good luck. We're all counting on you.